GM, what's up, clubbers? In today's video, what we're going to understand is how do we deploy a proxy contract, a contract that can be upgraded. Generally speaking, smart contracts are immutable, but there is some way through which we can sort of outsource execution of specific functions or any function for that matter and use this kind of a logic to create a smart contract that can be upgraded. We will understand what are the pitfalls, what are the gotchas of creating a smart contract which is upgradable, and what are the best practices to be able to do that. In today's video, we are going to use a simple smart contract which will help us explain how the upgrade works. Hopefully in the next video, we'll try to understand how do we do this with NFT or ERC20 token and stuff like that. But before we get started, please make sure to hit that like button and subscribe to this channel if you haven't. If you want me to read a message, please leave in the YouTube comments. I try to read all the comments that I get. And if you have a specific question, come join my Discord server. There are a bunch of people just like you and me who are hanging out there trying to help each other out. Alright, with that said, let's get started. So there are a bunch of proxy standards or ways through which we can generate an upgradable smart contract. The one we are going to focus on today is called Universal Upgradable POC Proxy Standard, also UUPS for short. The other standards which are available are little convoluted or maybe higher on the gas. This has a perfect balance of stuff which I really like. So if you go through the EIP, it's a very interesting EIP, but the core of it is here, the fallback function. The fallback function is called when the contract can't find a method which is being called. In the fallback function, what we do for a UUPS proxy is we delegate call to a different smart contract. Now, what does that mean? Delegate call is a special function which helps us execute with the transaction data on a different smart contract. So delegate call uses the logic of a different smart contract, the contract logic that we see over here, but with the state variables of the current smart contract. So whenever you deploy a proxy contract, that will be the address of your token or NFT or smart contract or whatever, and the logic will reside in a different smart contract. Now this EIP was written earlier when the Solidity syntax was a little different. Today when we actually go and write the proxy, it will look a little bit different, but the meat of it, the logic of it will remain the same. And we also have a sort of a sample implementation of the UUPS proxy over here. The first thing that we do is create a constructor. Now in the constructor, we have a specific storage slot. So every smart contract gets their storage in different slots in different areas. So what we do is we figure out this specific slot. And how is that slot figured out? By calling this function ksec256, which is a hashing function with the value proxyable. This returns us with this value, and this is the slot where we store the implementation smart contract's address. So what this line basically says is, at this location store this address, and then we will use this contract logic, the variable contract logic, which is stored at this location. We will basically use that over here in the fallback function. So as you can see, the contract logic is loaded like this, and then we delegate the call to that contract logic. So how does upgrading the contract work over here? You simply change the contract logic address to a different address, and that is how we are able to upgrade that smart contract. Now that part we don't really write in the proxy, we write it directly in the implementation. So if ever there's an implementation which does not have the option to update this logic, the smart contract is done. It can't be upgraded anymore. There's another small contract that they've written for us called Proxyable. If we just include this smart contract in our final smart contract, we get this method called update code address, which is basically the method that we need to upgrade this smart contract. We can simply call this method with only owner modifier and just work ahead with that. So now off camera, what I've already done is written the proxy.sol, the proxy smart contract over here. You can check it out. Let me just increase the font size. The smart contract is just copied from the UUIP, but I've basically made sure that it works for the latest Solidity compiler. And we also have this fallback function, which is external and payable, just so it works as we want. The next smart contract that I've written is the Proxyable smart contract, which is again very similar to how we had seen in the UUPS specification, and it has a function called update code address, which is an internal function. So this is a function that we will have to call from our own smart contract. And then at the end, I have this my contract, which has three variables: owner, count, and initialized. Now, one thing that you need to understand about upgradable smart contracts is that you can never change the way a variable was declared or defined. What do I mean by that? The next smart contract, whichever we want as an upgrade, will have to have these three variables in these specific order. If you don't have that, then the smart contract will not work. It will technically work, but it will just mess up the correct values that should be present for the correct variable. How it works in the backend is that these values are stored in slots on the chain. So the first variable that we receive will be stored in the first slot, the second is received in the second slot, and the third is in the third slot. If Proxyable here had any variables, they would have been actually in the first slot, and then the my contract would have it in the second and then third and then fourth slot. So make sure whenever you upgrade a smart contract, you don't change the order of the old variables. You can append new variables, but don't change the old variables. And then secondly, whatever constructor logic that you wanted, just don't put it in the constructor, because that constructor is never called by the proxy. So we create a new function which I have called here initialize, and this function actually acts like a constructor. This is the function that is called just after setting our pointer, our delegation to this smart contract. And this my contract basically has a variable called count, which has a function called increment, which I basically call to increase the count. And I have an update code function which receives a new code address. So if I want to update this specific implementation, I will just call the update code, and this will point to the new implementation. And of course, I have created an only owner modifier so that update code can only be called by the person who is the owner of this smart contract. Now, first, what you will do is you will deploy the my contract, the my contract.sol, and then you will receive the address for the my contract, which you will then give to the proxy contract while deploying it. So I've already deployed my contract, as you can see over here. This was deployed 42 minutes ago, and the proxy contract that I've already deployed was 39 minutes ago. So I first deployed the my contract, then I deployed the proxy contract. How do you deploy? I've already done that multiple times. If you are confused about how to deploy, check out my other videos. Every video I show how to deploy a smart contract. I've also written a simple HTML file which basically connects to the smart contract and then gives us a current value. So whenever I click this button, it basically gets the current value from the proxy smart contract. So you can see that if I click this increment button, this transaction pops up, which I can click confirm, and the value will increase as soon as the transaction goes through. It just takes a lot of time to go ahead. The Robston test network is very slow. And just like that, the value has increased to 4 because I have just incremented it. And you can see in the proxy address, in the proxy smart contract, not in the my contract, in the proxy smart contract, one transaction has increased, which was 1 minute ago. In the my contract, there has been only one transaction, which was to basically deploy this contract. So if I go ahead and click on the contract read, the count will show 0, but actually in our code, it is showing 4. Now to verify what this code does, I'll just walk you through the code. It has 3 buttons: connect, increment, and get current value. The connect button connects with the MetaMask. The increment button basically calls the increment function, and the current button basically finds the count of the variable and just updates the value on the UI. So if you see, the current value is 4, which actually compares exactly with the transactions. If you see, there have been 4 transactions of increment, so the value is 4. But on the my contract, you will see the value it shows is 0. I hope you understand why that is happening. Whenever we are interacting with the proxy smart contract, the state is stored in the proxy smart contract, but the implementation is stored in the my contract. So when I send the transaction to proxy smart contract, it is sent to the proxy smart contract, not the my contract. So you will see the transaction listed over here, and the state also changes for this specific proxy smart contract only. It doesn't change for the my contract. I can of course write contract over here and increase that value, but it will not affect the proxy smart contract. So I'm just going to increase and show it to you that the value is independent over here. Now the transaction has gone through. I refresh this page and the count value should now be 1. And you can see in the transactions as well, one more transaction is ought to pop up over here. There you go, there it is, the increment. The value that you will see over here now is 1. But if I just connect over here with the proxy smart contract, the value will be 4. Now another thing, just to show you that my contract is working independently, what I'm going to do is copy the my contract's address, and in the proxy, in the HTML, I'm going to paste the my contract's address over here and then hit refresh and connect. This time the current value is 1 because now it is directly asking the my contract and its state. But if I go back to the proxy smart contract and save and refresh and connect, now it's at 4. So proxy has its own state, my contract has its own state. When we are interacting with the proxy smart contract, we are only changing the state of the proxy smart contract, not of the my contract. Now, one thing that you will see is that there is no decrement function, it's only increment. The functions are only called increment. And now I want to add a function which decrements the count by 1. So how will I go about doing that? Well, it's very simple. You create the new contract, make sure the variables are in the correct order. You add the new methods and then deploy that smart contract. After that, in the proxy smart contract, you basically call this update code function, which is already present in the my contract, and add the new address that we have just deployed. Once that transaction succeeds, the proxy will point to a different smart contract, which will be the one that we have updated. Now, I've already in the ABI added the decrement function that you can see here that I'm just going to call now. And this function will give me an error because this function is not available. It is giving me an execution reverted because this function doesn't exist. So now what we are going to do is we are going to create a my contract 2, which is again proxyable, and I am going to add a new function called decrement, which is again a public function and reduces the counts value. I'm going to compile this. I'm going to go here and with the injected web3 selected and me being on the Robston network, select my contract 2 and deploy this. So once the deployment succeeds, we now will have to go to the proxy contract and call the update code method, which will help us update the code, the implementation logic. All right, so we are just waiting for the transaction to go through, and after that we will just copy the my contract 2's address and use that in the proxy address, or actually smart contract. Alright, the transaction has succeeded and I have received this over here. So I've just copied the address. I went back to the proxy that I've connected. I write contract over here, methods, update code. Now, one thing that you need to make sure is that you're connected with the owner account, because that is what I've written as only the owner can do this. So in the update code, I paste the new address and send out this transaction. It is asking me to pay for the gas, which I will easily give. And once the transaction succeeds, you will figure out. And now the transaction has succeeded. And so this time I should have a method called decrement. I can try to call it. It will give me an error because I haven't paid any gas. But you can see that it did not really give me an error. It just said that it does not work, which means the method is already available. So I call send on this with my account. All right, and I click on confirm, and once the transaction succeeds, we should see the value over here, which will be 3. The transaction has succeeded. Now I click on get current value, and the value has changed to 3 because we called the decrement function. And now if we go back to the proxy and refresh, we will see that I think we have 2 more transactions now, one for the decrement and one for updating the code. As you can see, one is for update code and the other is for decrement. So this is how basically a UUPS proxy works. Now the one thing that I haven't shown you is how to deploy a brand new UUPS proxy. All right, so let me just go back to the code. This code, by the way, will be available in the description down below. There will be a link and stuff, so you can of course use this. Yeah, so now again let me go back to the proxy code, and you will see that it requires 2 arguments. One is the construct data, which I will come to, and the other is contract logic. So the contract logic is where we basically give the proxy that this is the contract that we need to point to, and the construct data is the method that we need to call on the implementation contract, on the my contract as our very own constructor. So you can see that construct data is accepted over here, and the contract logic dot delegate call, which means with this contract logic, send this call to that contract and just give us the result. All right. So contract logic dot delegate call sends the construct data. Now the problem is that generating that construct data is not as simple as we think. One thing that I have already present is my contract too. So I can just copy that and I can paste the address over here. This will not be a problem for us. But now we want to figure out the construct data. And to figure out the construct data, I have this mycontract.sol. All right. Here I have this initialize function, which is basically the function that I want to call as the constructor. So I'm going to copy this function, and in the REPL here down below on the remix, or you can do it with any web3.js object, you need to call web3.utils.sha. Looks like there was some problem with my remix, but anyway, let me just type web3.utils.sha3, and then here we can go to the my contract, which is my contract 2 actually, and just copy this initialize and paste it over here, and this will give us the SHA-3 of this initialize function. Now but what I want is a substring. Basically I just need the first 10 letters, so 0 comma 10 is what I will pass as the argument, and this has given me the first 10 letters. So I'm going to select the proxy again, make sure that it is compiled. Then here I will basically paste the construct data that I've received over here, and then from the proxy contract itself, I can figure out what is the address of my contract 2 and just use that. So I'm just going to paste the my contract 2's address over here. Also make sure that you're injecting the web3 object and then click transact. So what we are going to do is we are deploying the proxy contract, and the proxy contract will be pointing to the my contract to implementation. So I click confirm, and now I wait for the proxy contract to propagate. Whenever I'm saying proxy contract, just try to understand that I am trying to say the main contract, the main address for your token, for your smart contract, for your NFT, whatever. This is the address with which the users will be interacting. The transaction has gone through, and I can just copy the proxy smart contract and paste it over here. Now, if I go ahead and refresh the page and click connect, the current value will be 0 because this is a new proxy contract that we have deployed. Alright then, thank you so much for watching the video. This is how you create a proxy smart contract, an upgradable smart contract. The proxy is the main contract with which the users interact, and then you have an implementation smart contract which the users can then later talk to. First, you deploy the logic smart contract, then you use the address and the call data value, and then give those values to the proxy smart contract, so that when the proxy smart contract is deployed, it calls the initialize function or whatever function you want to call it, and makes sure that the proxy is pointing to the logic. And how does the pointing work? We basically have this function in Solidity called delegate call, which calls the other smart contract with the context of the current smart contract. So the states, the variables, everything is from the current smart contract, but the logic is stored in a new different smart contract. With the upgrade, the proxy smart contract's address doesn't change, which is the address with which users interact. What changes is the logic smart contract. Now there are a few pitfalls that you need to make sure that something is not become a problem. So for example, the initialize function that is called, it sets the owner. So make sure that this function isn't called by somebody else again. Otherwise, somebody else can take the ownership of your smart contract and do nasty things with it. Hopefully in the next video, what we'll discuss is how do we use an ERC20 token or an ERC721 token with a proxy smart contract with an upgradable smart contract. If you like this video, please make sure to hit that like button, subscribe to this channel if you're new here. If you want me to read anything, you have a message for me, please leave it in the YouTube comments. Or if you have any specific question, come join on my Discord server. There are a bunch of people just like you and me who are trying to help each other out. Thank you so much again for watching the video. I hope to see you again probably next week. Till then, bye bye.